I wanted to review topic 9. I'll show you those few things about how to convert the function back into a regular script. Um, as far as the algorithm goes, I think this will make the most sense for different types of interpolation and what they mean. So first, remember that for the exam and everything, what I'm expecting out of this topic is first that you have a theoretical understanding of what interpolation is. In that, like, if I asked you to apply it, by hand, you would understand conceptually what that would mean. Or if I asked you a theoretical conceptual question on interpolation, you'd be able to interpret the idea of it. So, like, it has nothing to do with the algorithm other than the fact that you also are using the algorithm when you apply it, but you might not be thinking of it that way. You should definitely be familiar with how to use interp 1 for this topic because we've used it a lot. I think the thing that I see everyone doing is not putting in 3 inputs, and it's not, in this case, it's not a syntax thing. It's not like, oh, I want you to memorize that there's 3 inputs. It's a very conceptual thing. If you don't realize that there needs to be 3 inputs, to me it shows that you don't really understand the concept of interpolation, because it really doesn't make sense to not give it anything less than 3, because it needs to know its x, its y, and what it's interpolating to. So that's why I focus so much on the interp 1 intrinsic function in this particular topic. As far as the algorithm and the programming side of this topic goes, the first thing that you need to be able to understand is the window interpolation algorithm, which is the part of the algorithm that locates the 2 points that bracket your starred value. And so that's the one that you're going to use for all these different interpolation types. The formula for linear interpolation, you should know. It should be on your card and everything. You'll need to use it on the exam, but that's not really. That's sort of like you should have already known that before. It's kind of like background that you should have. I'm not going to be asking you specific questions on whether or not you know that. You'll need to use it if you're applying it to a question, but it's not like that's far below what my expectations are for this topic. And then the last thing is this is another lab where we got to use nested for loops. And so to understand that concept, the last nested for loop that we used in the population algorithm was different because the nested for loops were like going through each coordinate of your grid. One was going in the x direction, one was going in the y direction. This nested for loop is different because one loop is in charge of all of the starred values that it's finding, and the other loop is in charge of locating the bracket. So making sure you really understand that algorithm. So here is a plot of all the different interpolation options in the interp1 function. So you should have seen these when you had to look up how to do one of these. I hope you guys looked at this for both linear and when you did Cody coursework. And then I've just plotted them to show you. So the blue is the data, and the point that you're interpolating is right here at 2.5. And all these different y values show what the different interpolations would give. So linear is what we programmed first, so that's going to connect a straight line between the 2 points and plot the y value on that straight line. The one that you did in Cody coursework was previous. That means it's going to locate the 2 points, y1, y2, and it's going to set the y star value to the y1 value, the one before it, the previous one. So that's why you can see that the x for previous is on the y value before it. The next would be set to the y2 value, and then the nearest, which is normally what I have the students do as their quiz for this topic, is write the nearest algorithm, is to compare the distance between these 2 x values and these 2 x values and choose the one that's closest. Rather than the one before or the one after. It locates whichever one's closest and sets the y value to that. So the only thing that changes Now, I wrote my algorithm a little bit different than what I saw everyone else write, but which is fine. I just used a while loop. So I have my outer for loop that goes through my x star values, and then my inner loop, which finds the bracket. So basically, once x star is greater than the x value, it saves the j location. And so then I know which j location I'm at, and then I just use that index to find the two bracketing points. And then these if statements just do all those I just showed you: previous, next, nearest, and linear. And so if you're doing just one of them, just one of these lines would be there. The only thing that changes is the way you set y star. So if you were doing previous, y star gets set to the y value on the left, but your indexing might not be j minus 1. For most of you, it was probably j or I, just their single index, because everyone was almost doing j and j plus 1 or I and I plus 1 as the 2 points. So that's just all how you kept track of it. So that's how the algorithm works. As for my my tips and tricks for this topic, the thing that I start noticing that people start doing a lot around this time is the for loop. Even though most people will do it correctly previously, they'll get in the habit of just putting one number in the for loop. And I told you that when I first presented it to you, that some people think, okay, I want the for loop to run 10 times, so I'm going to write I equals 10. But remember, that only runs it one time. So you have to put an array, and the loop runs for each element